Hope you can see the screen. Can you see the board? Okay, right. So I shall just brief again. So last class we discussed Varignon's theorem of moments. Now, Varignon's theorem of moments say that if you consider a set of forces acting in a plane, then the algebraic sum of moments due to the component forces with respect to a point is equal to moment made by the resultant at that point. So that is Varignon's theorem of moments. Somebody admit. Okay. So that is Varignon's theorem of moment. To illustrate that theorem, I've taken a plane, right? A plane here, where there are two concurrent forces acting at a point A, force F1 and F2. These two forces make a resultant R. So I selected a point B in this plane, right? And then I'm trying to apply this theorem there. So first I'm taking forces one by one. Say first I have taken the force F1. Moment due to the force F1 at B is given by F1 D1. It is going to create a anti-clockwise moment. So sign is positive. So moment due to F1 at B is plus F1 D1. Similarly, let's take the next force F2. Right? Moment due to F2 at B is F2 D2. Again, this also will produce an anti-clockwise moment. So plus F2 D2. So the algebraic sum of the moment due to the components means you add up these two. So that is F1 D1 plus F2 D2. Now if you consider the resultant R, moment due to the resultant R at B is given by RD. Again, it is an anti-clockwise moment, so plus RD. So if you apply this theorem, you can say that RD is equal to F1 D1 plus F2 D2. So this is what you call as Varignon's theorem of moment, and this is a very useful theorem for solving problems in mechanics, especially parallel forces. Okay. Next, what we need to do is we need to have a proof for this Varignon's theorem. So today we shall discuss a proof for Varignon's theorem. So I'll go to the next page. So for a proof for this, I'll write proof for Varignon's theorem. I'm going to select two concurrent coplanar forces, right? So for that, I'm selecting an XY plane. I select some point here. So select a point here. I select a point here. So this is the X direction. And I consider a vertical line. So this is your Y direction. Right. So I've selected an XY plane. So this is X and this is Y. Origin is O. I consider two forces acting at a point O. Okay, so I have one force here. One force here. and suppose that force is F1, a force F1, say making an angle theta 1 with x direction, and you have another force F2. So you have another force here. Say make it like this. Say a force F2. So this is F2. Again, suppose this force is making an angle. Let's mark here theta 2. There are two forces acting, two concurrent forces acting. Now these two forces will be having a resultant. So if I try to find the resultant, suppose I construct a parallelogram. Writing in a parallelogram here. Right, and then I'll use a different color, maybe that is fine. Where the color we can. Draw line parallel to F1 Varignon. Draw a line parallel to F2. So you get your resultant R. So this is resultant force R. And suppose this is making an angle theta with x-axis. Right? So there are two forces F1 and F2 and a resultant R, all acting at a point O. Now suppose I select a point in this plane. Say I select a point here, A. Somewhere here I select a point A. Suppose I select a point A here. I'm going to take moments with respect to that point A. Now what does the theorem says? Theorem says that algebraic sum of, I'll write here, algebraic sum of moments, moment due to components so take algebraic sum of moment due to components. This is equal to moment due to resultant. Right? So this is Varignon's theorem. Mathematically we can express this as algebraic sum of moments. You can write it as sigma m. It's a summation is equal to moment due to the resultant. Suppose R is your resultant and it distance from that point that we select is x, so it is sigma m equal to Rx. So in this particular case, we have selected a point A here, right? So if we consider the moments, if I take the moments, if you take the first force F1, how will you take moment due to F1? You have to drop a perpendicular from A to F1, perpendicular over here. Right. suppose that distance is d1. Say this distance is, say, d1. Put back. So this is d1. Moment due to the force F1 at A is given by F1 d1. And this force is going to make an anti-clockwise moment. So this is positive. So plus F1 d1. Similarly, moment due to the force F2 is given by force into its perpendicular distance. So still again, you need to draw a perpendicular from A all the way to the force perpendicular. Right. Suppose that distance is d2. So this is d2. Moment due to the force F2 at A is given by F2 d2. Again, this force is going to produce an anti-clockwise moment. So this will be F1 d1 plus F2 d2. Right. So this is what we call it as the algebraic sum of moment due to the components. Now the theorem says that this should be equal to moment due to the resultant. So resultant force is R into the perpendicular distance of the line of action of R from A. So again, you should go back to your figure. Right? Drop a perpendicular from A all the way to R. Right? Say this distance is D. If this distance is D, right? This, so R into D. So this is the moment due to the resultant. And this we say that the expression for Varignon's theorem of moments. Now, if you want to find a proof for this, right, you take one by one. Suppose you take F1 d1, I'll write here, say F1 d1, that is moment due to the force F1 at A. So this is given by F1 into, so instead of d1, I will give another expression for that. Suppose this angle is θ1, how much will be this angle here? I just like, how much will be this angle here? If F1 makes an angle θ1 with x direction, what will be the angle made by its perpendicular with y direction? This angle here. How much will be that? Can someone tell me? This will also be θ1. If the other angle is θ1, so this angle also will be θ1. Okay. So if you consider a right triangle here, say you have a point here, OA, suppose this point is B here, I'll write B. If you consider a triangle OAB, right, D1 you can write it as OA cos θ1. So instead of D1 you can write OA cos θ1. So F1 into OA cos θ1. If you just rearrange this, you find it F1 cos θ1 into OA. But what is F1 cos θ1? You are resolving the force F1 along x direction. Right? So that is F1 cos θ1. Right? I'll use a different color. Maybe if you draw a perpendicular here from F1 all the way down, this term is Fx1. Right? The component of the force F1 along x direction. So I can write this as Fx1. That is nothing but F1 cos theta 1. So instead of this term F1 cos theta 1, you can write it as Fx1. So this becomes Fx1 into OA. Right? Now, similarly, if you take the next component F2, just change my color. Say F2 into D2, in a similar way, you can find that if F2 is making an angle theta 2 with x direction, its perpendicular D2 will be making an angle, say this angle, suppose here, this will be theta 2. I'll write it outside to avoid confusion. So this angle here will be theta 2. Right? So instead of D2, you can write it as OA cos theta 2. So it will becomes F2 into OA cos theta 2. Or if you just rearrange this, it will becomes F2 cos theta 2 into OA. Now, as I did earlier, I'm not going to draw it again. This term F2 cos theta 2 is Fx2. Or you can write this as Fx2 into OA. Clear? So if you look at the left hand side of the equation 1, so suppose this is equation 1. Suppose I call it as equation 1. If you look at the left hand side, you can write it as F1 D1 plus F2 D2 is given by Fx1 into OA plus Fx2 into OA, or if you take the common factor out, you can write it as Fx1 plus Fx2 into OA. Right? Now, what is this Fx1 plus Fx2? That is the net force along the x direction. So you can write it as Rx into OA. Now what is Rx? The x component of the resultant. I'll put it as Rx. So instead of Rx, you can write it as R cos theta into OA. Right? Now, what is R cos theta into OA? Cos theta into OA, right? So again, if you apply the similar theorem, so if this angle is theta here, and I'll just change my color. This D will also make an angle theta. Say if you consider this angle here, it's a different color. This angle is theta. So OA into cos theta is nothing but D, this term D here. So instead of R cos theta into OA, you can write it as come here. So this is R into D. which is your right hand side. Right? So hence the proof for Varignon's theorem. So this is how you prove Varignon's theorem of moments. മനസ്സിലായോ നിങ്ങൾക്ക്? ഫോളോ ചെയ്യാൻ പറ്റുന്നുണ്ടോ? Is there any doubts here? I'll go back to my video. Clear ആയോ? Is there any doubts with Varignon's theorem of moments? ഇത് എക്സാമിന് ചോദിക്കാറുള്ള ഒരു ക്വസ്റ്റ്യൻ ആണ്. നിങ്ങൾ നോട്ട് ചെയ്തോ അത്? I'll ask somebody. Aisha.
സർ മനസ്സിലായി.
മനസ്സിലായി. ഓക്കെ, റൈറ്റ്. അപ്പൊ നോട്ട് ചെയ്തോ ക്വസ്റ്റ്യൻ? ഇത് എഴുതിയെടുത്തോ എല്ലാവരും? I'll ask somebody else. Say Karthik.
ഹലോ സാർ.
എഴുതിയെടുത്തോ?
എഴുതി.
ക്ലിയർ ആയോ?
ക്ലിയർ ആയി.
Okay, right, fine. So I'll again go back to my video. So this is the proof for Varignon's theorem. So this question used to come for exam, right? State and prove Varignon's theorem of moments. Now we need to try some numericals where we find the application of Varignon's theorem of moments. Mainly you find it in coplanar forces, right? So I got a question. Right? Can you note down this question? There is a system of coplanar forces given, coplanar parallel forces. The question is, determine the resultant of the system of forces shown in the figure. There are 4 parallel forces acting. Can you note down this question? This is 7 meters here. Just put it like this is 7 meters. Right. So there are 3 things here when it comes to parallel forces. You need to find the magnitude of the resultant force, the direction of the resultant force, and third, the point where this resultant acts. So 3 things: magnitude, direction, and the point of action. 3 things you need to find. Let's find the magnitude of the resultant force. How will you find the magnitude of the resultant force here? Right? So in general, we say that you sum up all the forces in x directions. You write it as sigma fx. That means you are going to add all the forces in x direction. Now, in our case, there is no forces in the x direction, so fx is 0. Next, you add all the forces in y direction, right? So sigma fy. Take the positive y direction as positive the negative y direction is negative. So if we add all the forces, we can write it as 10, which is acting upward, it's positive. Sorry, that is minus. It is minus sign here. Right? 10 acting downward, minus 10, plus 20 acting upwards. Right? So 20. The third force acting downwards, so minus 20. And the fourth one is also acting downwards, so minus 10. Right? So net, you find that Fy is minus how much? Minus 20 kilonewton. Right? So, in short, there is a negative force, right? That means this Fy is acting downwards. Right? So, you can write it as 20 kilonewton acting downwards. So, that is the direction of the force. So, we take that negative sign out. So, 20 kilonewton acting. So, that is the resultant force, right? Yeah, theoretically, we say that R is given by root of Fx squared plus Fy squared. So in our case, Fx is 0, so we'll reduce it again the same answer, 20 kilonewton, which is acting downwards. So we got the magnitude and direction of this force. Next is we need to find where does it act. Right? Where is this 20 kilonewton acting? Right? Suppose it is acting at some point in between these two. So it's there that your Varignon's theorem will help you. Suppose this 20 kilonewton is acting here. Resultant force is acting here. So this is your resultant R. This is our assumption. We don't know. We assume that it is acting here, R. Now, where is this point A? Suppose this point is, say, B. How will you define this point B? That is the next question. So it is here that the Varignon theorem will help you. So what we need to do is we need to apply Varignon's theorem here. Right? Suppose, say you take a point in this plane. Say I selected this point here, A. I'm going to apply Varignon's theorem to this system of forces with respect to point A. Now suppose the distance of R from A, suppose this distance, right? Suppose this distance is X. Suppose this distance is X. You're going to apply Varignon's theorem. So what does Varignon's theorem says that algebraic sum of moments due to the components with respect to a point is equal to moment due to the resultant, right? So you can write it as sigma m a. So this is what you call it as algebraic sum of moments due to the components is equal to the moment due to the resultant, right? So R, so in our case, R into X. So this is Varignon's theorem. So we need to find an expression for sigma ma. So what is sigma ma? That is moment due to the algebraic sum of moment due to the components. You take forces one by one. So you take, let's start from this end. So you have a 10 kilonewton force, right, acting at point A. So what is the moment due to this force 10 at A? Force into perpendicular distance. Since it's acting at A, that will be equal to 0. You go to the second force, 20, right? What will be the moment due to 20 kilonewton at A? That will be 20 into its perpendicular distance, which is 4. Now, what is the direction? It will produce an anti-clockwise moment at A. So this will be minus. So this is very important. You should understand this. It's minus 20 into 4. You go to the third force, this 20 kilonewton, right? So that moment due to that 20 kilonewton will be 20 into 10. 6 plus 4 is 10. Right? Now what will be the direction? This 20 kilonewton will be causing a clockwise moment at A. Right? So this will be minus. So minus. This was anti-clockwise, no? So this is positive, sorry. This was positive. This is producing anti-clockwise, so positive. This is clockwise, so negative. Now we come here, 10 kilonewton force. Again, the moment due to this 10 kilonewton force is... Yes, Parnolu.
10 താഴത്തേക്കല്ലേ?
ഏത് 10 ആണ്? എക്സ്ട്രീം ലെഫ്റ്റിലുള്ള 10 ആണോ? ഈ 10 ആണോ ഉദ്ദേശിക്കുന്നത്? അതെ, 10 താഴേക്കാണ്. ബട്ട് ഇറ്റ് ഈസ് ആക്ടിങ് അറ്റ് എ. അത് മൈനസ് ആയാലും കുഴപ്പമില്ല. കാരണം എന്താ വെച്ചാല് ഐ കൻ പുട്ട് ഇറ്റ് ആസ് നെഗറ്റീവ്. കാരണം അത് മൊമെന്റ് ഉണ്ടാക്കുന്നില്ല. കാരണം ഇത് എ എന്നുള്ള പോയിന്റിൽ കൂടെ തന്നെയല്ലേ പാസ് ചെയ്യുന്നത്. മനസ്സിലായോ? അത് 0 ആയി പോകും. അപ്പൊ നെഗറ്റീവ് ആണെങ്കിലും പോസിറ്റീവ് ആണെങ്കിലും ഇറ്റ് ഡസ് നോട്ട് മാറ്റർ. ഇത് 0 ആണ്. ക്ലിയർ? അതുകൊണ്ടാണ് ഞാൻ അവിടെ നെഗറ്റീവ് സൈൻ ഇടാഞ്ഞത്. ക്ലിയർ ആയോ?
ക്ലിയർ ആയി സർ.
Okay, right. Now you go to the fourth force here, 10 kilonewton. Right? It is acting downwards. Right? So it will have a moment at A. So that will be 10 into its perpendicular distance. No, 6 plus 4 plus 7, it is 17. Right? What about its sign? It's again producing a clockwise moment. So this will be negative. So this is what we call it as sigma MA. So that is the left hand side. Now the right hand side is R into X. So in our case, what is R into X? R is 20 kilonewton. So 20 into X, we don't know. That is what we need to find. What will be the direction? The sign, it will be negative. So since it is a clockwise moment, so it is negative. So if we equate these two, we find that 0 plus 20 into 4 minus 20 into 10 minus 10 into 17 is given, but this is equal to minus 20 into X. So from this, you get a value for X. So much you got? Can you just calculate? Yeah, correct. 14.5. So get this value as 14.5. So much meters there. So this X is 14.5. So this is the use of Varignon's theorem of moment. Right? This is one of the applications of Varignon's theorem of moment to find where this resultant acts. As I told in the beginning, there are three things. One is the magnitude, that is 20 kilonewton. Another is the direction, which is acting downwards. Third is where does this resultant act? That means you need to locate this point B. For that, this Varignon's theorem of moment will help. I hope it is clear. Is there any doubts here? Anybody?
സാർ ഒരു കാര്യം ചോദിച്ചോട്ടെ.
Yes.
നമ്മുടെ റിസൾട്ടന്റ് ഡൗൺവേർഡ് ആണെന്ന് നമുക്ക് എങ്ങനെ മനസ്സിലാവും?
അതായത് നമ്മൾ ഒരു XY കാർട്ടീഷ്യൻ കോർഡിനേറ്റ് സിസ്റ്റം പോലെ കൺസിഡർ ചെയ്യുകയാണെങ്കിൽ ഇത് എക്സും ഇത് Y അല്ലേ? അപ്പൊ മുകളിലോട്ടുള്ളതെല്ലാം നമ്മൾ പോസിറ്റീവായിട്ട് എടുത്തത്, താഴോട്ടുള്ളതൊക്കെ ഇതും പോസിറ്റീവായിട്ട് എടുക്കുന്നു. നേരെ ഓപ്പോസിറ്റ് ഉള്ളത് നെഗറ്റീവാണ്, താഴോട്ടുള്ളതെല്ലാം നെഗറ്റീവായിട്ട് എടുത്തു. മനസ്സിലായോ? അപ്പോൾ നെഗറ്റീവ് Y ഡയറക്ഷൻ, ഇങ്ങനെ അടിയിലേക്കുള്ളത് നെഗറ്റീവ്, ഇങ്ങനെ നമ്മൾ എടുത്തിരിക്കുന്നത്. അപ്പൊ നമ്മൾ ഇക്വേഷൻ എഴുതിയപ്പോ this 10 is acting downwards, so you got a negative sign here. You put negative. This 20 is acting upward, so you put positive. The next 20 is negative, and finally this 10 is also negative. So after adding all these, you got a value as negative. So this negative sign indicates that it is acting downwards. Clear? മനസ്സിലായോ? Just because you got this negative sign here, അതുകൊണ്ടാണ് താഴോട്ടാണെന്ന് മനസ്സിലായത്.
ആഡ് ചെയ്യുമ്പോൾ നെഗറ്റീവ് കിട്ടുന്നു, അപ്പോൾ റിസൾട്ടന്റും നെഗറ്റീവ് ഡൗൺവേർഡ് ആയിരിക്കുമല്ലോ.
നെഗറ്റീവ് റിസൾട്ടന്റ് ആയിരിക്കും. അതായത് ഈ കേസിൽ ഈ R കണ്ടുപിടിക്കേണ്ട കാര്യമില്ല, കാരണം ഓൺലി വൺ ഫോഴ്സ്, എല്ലാം വെർട്ടിക്കൽ ഫോഴ്സസ് മാത്രമല്ലേ ഉള്ളൂ. അതുകൊണ്ട് തന്നെ അത് നെഗറ്റീവ് ആയിരിക്കും, മീൻസ് താഴോട്ടായിരിക്കും. ക്ലിയർ ആയോ?
ക്ലിയർ ആകും.
Okay, fine. Now I'll go to the next question. Determine the resultant of the system of forces acting on a beam as shown in the figure. Can you just write down the sentence? The question I shall draw. Figure ഞാൻ വരയ്ക്കാം. So there is a consider a horizontal line. You consider a horizontal line. Suppose this is AB. ഒരു ലൈൻ AB കൺസിഡർ ചെയ്യുന്നു. There are various forces acting on this line AB. So you have one force here. Oh God. Reduce the thickness. ഒരു force ഇവിടെ, ഇങ്ങനൊരു force. Another force here. Two forces, and a third force somewhere here, but it is inclined. There are three forces. Now, the first force is 20 kilonewton. Second is 30 kilonewton. And the last one is again 20 kilonewton. Moon forces. So if you look at the distances, suppose this distance is 1.5 meter. I'll put 1.5 meter. Distance between these two is again 1.5 meter. This distance is 3 meters. To avoid confusion, maybe I'll put some arrowheads. Line വരയ്ക്കാം. So I'll go back. ഈ ഡിസ്റ്റൻസ് ഇവിടെ നിന്ന് എടുത്താൽ ഇത് 1.5. Take everything in meters. This is again 1.5. This is 3. This is 3 meters. And finally, sorry, ഇവിടെ വരെയല്ല. Like control താഴെ വരയ്ക്കും. So this distance ഇവിടം വരെ. If I draw a vertical line here, so this is 3 meters. And this is 2 meters. ഇങ്ങനെ ഒരു question. And this angle is 60 degrees. Suppose this angle is 60. So there are two vertical forces and an inclined force. You are asked to find the resultant of the set of forces. So how will you do this? The difference is there is an inclined force also here, like inclined force. So we need to consider this inclined force also. So for that, what you need to do is you have to resolve those forces. Right? So if you consider 20 kilonewton force, I'll take a different color. Right? You have to first resolve this 20 kilonewton force into two components, one perpendicular to the line AB and another one parallel to this line AB. So that if this is 20 kilonewton, this angle will be 60. So this component which is acting downwards, I'll put it as Fy, will be 20 into cos 60. And this component Fx, suppose I put it as Fx, is 20 sine 60, assuming that this is F. So I call this force as F. So this is the first thing that you need to do. You have to resolve the inclined forces into X and Y directions. By doing so, now we'll have forces only in the X and Y directions. So again, you need to find the resultant. So if I take Fx, sigma Fx, that means I'm going to add up all the forces in X direction, right? So that will be minus 20 sine 60. Again, the same convention that I've taken earlier. The positive X direction is positive, and all the forces in the negative X direction I take as negative. So I take this as negative, so many kilonewton. So you get a value here, minus so much kilonewton. Similarly, you add up all the forces in the Y direction, you put it as sigma Fy. Now we have all the forces in the negative Y direction, right? So it have minus 20, minus 30, minus 20 cos 60. Right? Again, so you get a value here. You get a negative value here, minus so much kilonewton. Right? So you need to calculate this. So Fx, you will get it as 10 kilonewton. Did you get it? 10 kilonewton. And this will come around minus 67.32. So did you get this answer?
സാർ അത് 10 ആണോ കിട്ടുന്നത്?
ഏതാ?
മുക്കത്തെ Fx.
Fx, how much? Right. Sine 60 ആണല്ലോ അല്ലേ? അല്ലേ, how much you got? I just changed it.
10√3 അല്ലേ?
അതെ, correct. I got a mistake there. So how much you got here?
10√3 അല്ലേ?
10√3 അല്ലേ? Okay, fine. അതിന്റെ വാല്യൂ എത്രയാ 10√3 എന്ന് പറയുമ്പോൾ?
17.3.
17.3. Fine, correct. ഇതോ Fyയോ? So this is half, so it 60. Okay, 60. Okay, right. Now you can find the resultant force and its direction, right? So resultant force means you have to represent this graphically, as I used to tell you earlier. Okay. Now there are two forces, Fx and Fy, both are negative. So you have one force in this direction and one force vertically acting downward. So this is your Fx, right? 17.3. I'm not taking negative sign because I already taken the direction, right? Suppose this is 0.0 and this is 60. That is your Fy. So you need to represent these two forces graphically And then you will find the resultant. So resultant will be in between these two. ഇങ്ങനെയായിരിക്കും നിങ്ങളുടെ റിസൾട്ടന്റ്. Resultant will be acting here. So this will be R. So this will be R. And this angle here will be the direction of the resultant, alpha. Okay, so I'll just put it here. I put it here. So what will be R? R. So R will be root of fx squared plus fy squared. So that will be equal to square root of 17.3 the whole squared plus 60 squared. So get a value for R, so many kilonewton, so much kilonewton. And also you need to find alpha. Alpha is tan inverse Fy by Fx. So here, since you have already taken the sign, you need not take the sign again. So this will be tan inverse Fy is 60 divided by Fx is 17.3. So you get a value for alpha. So this is the first step. You find R and then alpha. How much you got R? Can you tell me now? R is how much? Did you calculate R? So anyway, try to complete it as homework. Okay. We'll continue in the next class, and then we will find where does this resultant acts. Okay, so I'll just stop here. It's this time.
Sir, attendance.
Attendance at come. Fine. Just stop my recording.